Beyond the warmth of the sun, past the 4 rocky planets, and further than the gas giants, at the very distant edge of our solar system, lie 2 worlds we are only just beginning to explore and understand. They are the ice giants, Uranus and Neptune. These planets, dozens of times the mass of Earth, are so distant that humanity has only managed to visit them once. In 1977, the Voyager spacecraft embarked on a 12-year mission to reach what was once considered unreachable. Through this journey, we not only learned about these massive, icy worlds, but also about the satellites that orbit them, some of the iciest, most remote moons in the solar system. Among Neptune's moons, one stands out, Triton. Triton, a captured world. Triton is a special moon with properties we never imagined objects so far from the Sun could possess. However, it wasn't until 1989, when Voyager 2 flew by, that we began to unravel its true origins. Triton is a captured world, snatched from its original orbit by Neptune's gravity. Today, we will explore Triton's story and how it came to be the standout moon of the ice giants. The discovery of Triton. Triton was discovered just 17 days after Neptune itself, on October 10, 1846, by astronomer William Lassell using a self-constructed telescope. Initially, it was named a satellite of Neptune, a title it held for over 100 years. In 1949, when a second moon of Neptune was discovered, the first was renamed Triton, after the son of the Greek god Poseidon, who corresponds to Neptune in Roman mythology. At first glance, Triton appears to be a child of Neptune. At 2,700 kilometers in diameter, it is the largest of Neptune's 14 known moons, accounting for over 99% of the mass of all the planet's satellites. This makes it the 7th largest moon in the solar system and 20% larger than the dwarf planet Pluto. Composition and surface. Triton is composed primarily of ice and metal, with a rocky, metallic core encased in layers of water ice. Some speculate that subsurface oceans may exist beneath its frozen surface. It is estimated that Triton's composition includes between 1/6 and 1/3 water ice. On its surface, however, Triton has a unique feature: frozen nitrogen. In the frigid environment of Neptune's orbit, even nitrogen gas becomes a solid. Triton's surface is covered in a frosty layer of nitrogen ice, marked by cracks and icy lava flows. This nitrogen layer reflects over 70% of the sunlight that reaches the moon, but even so, faint sunlight affects the surface. Triton's nitrogen covering exists in a delicate balance. Its average surface temperature is a bone-chilling -235 degrees Celsius. A change of just a few degrees can disrupt this balance, leading to a remarkable phenomenon: geysers at Triton's geysers and atmosphere. Triton is covered in geysers that erupt material over 8 kilometers into the air. These eruptions are driven by sunlight warming the nitrogen ice. A temperature increase of less than 5 degrees Celsius can turn the frozen nitrogen into gas, causing it to burst through the surface, carrying water ice and dark material with it. This process constantly reshapes Triton's surface and also contributes to its thin atmosphere, composed mostly of nitrogen with traces of methane. Despite its thinness, this atmosphere supports wind currents and even clouds. The mystery of Triton's orbit. Triton's orbit provides clues to its origins. Unlike most moons, Triton orbits Neptune in the opposite direction of the planet's rotation, a retrograde orbit. This unusual motion suggests that Triton did not form with Neptune. Scientists now believe that Triton originated in the Kuiper Belt, a distant region of icy objects beyond Neptune. Its composition and size closely resemble that of Pluto, suggesting similar origins. Triton's capture by Neptune. If Triton was born in the Kuiper Belt, how did it become a moon of Neptune? The leading theory is that Triton was captured by Neptune's gravity during a close encounter. It may have collided with a moon or dwarf planet, slowing it down enough for Neptune to capture it. Alternatively, Triton might have had its own satellite, which was disrupted by Neptune's gravity. Once captured, Triton's initial orbit was likely chaotic and elliptical. Over time, Neptune's gravitational forces smoothed its orbit into the one observed today. Triton's geological activity. The tidal forces exerted by Neptune on Triton created friction, heating the moon's interior, a process known as tidal heating. This process made Triton geologically active, with geysers and volcanic-like activity shaping its surface. Triton is one of only 3 geologically active moons in the solar system, alongside Jupiter's Io and Saturn's Enceladus. The future of Triton exploration. Triton remains a mysterious world. Since the Voyager LY, no missions have returned to this distant moon. Proposed missions, such as NASA's A Triton A Flyby or the innovative A Triton Hopper, aim to uncover more about this icy world. One of the most exciting prospects is the possibility of a subsurface ocean, which could harbor the building blocks of life. Triton's organic-rich surface and geological activity make it a compelling target for future. Triton's story is one of transformation. Once a wanderer of the Kuiper Belt, it now orbits Neptune as a unique and dynamic moon. Triton challenges our understanding of icy worlds and the potential for life beyond Earth. With each discovery, we inch closer to unlocking the secrets of the outer solar system. Who knows what other marvels await us in the darkness?